In this tutorial we're going to talk about the rotational kinetic energy, and imagine, as previously when we talk about rotation, that we have a rigid body and it has, for instance, an axis of rotation, and it has, for instance, a radius, and this is for instance rotating with an angular speed. It could be an angular speed omega, and from previous explanations we understand that each and every particle that is generating or that is rotating with this rigid body has the same angular velocity, but not the same tangential speed. And each and every one has mass, right? So, for instance, we're going to state that each element has its own kinetic energy, and we state this is a differential because this is from an element, and this is going to be equal to 1/2 of its mass, which is a differential of mass, times its own velocity, the velocity of each element, to the square. And each element is having, for instance, the same omega, which is the angular speed. So we can state, for instance, this is r omega squared, being for instance the radius is going to be the distance from each element, the distance from the axis of rotation towards where the element is located. We can add all of this up in an integral, such that the kinetic energy of all the element is going to be 1/2 of the integral, or the sum of each contribution, of r squared dm times omega squared. And this guy, for instance, by definition from previous explanations, we know is the moment of inertia. So the kinetic energy for rotation is 1/2 moment of inertia of the body times omega squared. And remember that the moment of inertia is defined for each body, and it's also defined by the parallel axis theorem. So you can look for this in previous tutorials. Then let's suppose that we have some situation where this is rolling, and the rolling motion is an object which is translating in time. So we have this situation, any given object which is moving and is translating in time. It has an omega, a rotational or angular velocity, but it also is traveling with an speed, right? So this looks something like this. It moves a little bit, and then it moves a little bit once again, and this element, for instance, is moving in space, right? So this is rolling. The kinetic energy for this guy is going to be equal to 1/2 of mass velocity squared, because this is the translation, plus 1/2 of moment of inertia omega squared, because this is rotation. And this phenomena is called rolling motion. Anything can roll. So this is the kinetic energy for an object which is moving with a rotation and a translation.